Hello, this video is going to show how we can perform robustness testing. Now, I have some C++ code and I've already tested it, and as we can see I have 100% statement coverage and 100% branch decision coverage. But what happens if I invoke this class with parameters that are maybe outside the range? Is it going to be robust? Well, let's find out. Now, this is tbrun. And as we can see, I have a number of test cases here testing this static linked list. And as we can see, I've executed the tests, they've all passed, and I've got 100% statement and 100% branch decision coverage. Now let's go and create a new sequence, and we'll call this robustness test. Robustness test. Okay. Right. And now I want to test just the static linked list. And I want to generate code coverage. I want to automatically generate stubs, automatically create user globals, and we'll do a test build as well. So now this is just doing a test build, that built. So now I can perform what we call the extreme test. And in this particular case, we have a number of options that I've set. So for instance, I don't want to use null cases for pointer variables. But as we can see, I've set a number of other options. So let's go and try this. So I'm simply going to right click on the static linked list, and I'm going to run what we call a tabular extreme test. And this is trying to generate as many test cases as possible in order to try and maximize the code coverage. So, looks like it's actually crashed. So in this particular case, we can see we have a while. And if we take a look at pos node, we can see that's equal to 0. So of course we're dereferencing a null pointer and it's crashing. So looks like we need to just continue here. Let's do a quit. And this is now going to execute the test cases a second time. But this time it's actually going to suspend the test that failed. So there we can see test case 13 was testing the function remove last. And that's the function that's caused the crash. And as we can see, it looks like it's actually setting root node next equal to null. Well, let's take a look at the source code and maybe let's see where that occurs. So this was in the function remove last. So there we have the remove last. And here we can see we're setting pos node equal to root node next. So that's really where I want to be able to do some testing. So let's just update that code. So there we can see now I'm actually going to test to make sure this is null. If it is null, I'm going to return false. Otherwise, I'm then going to access that. So that looks much better. Let's just format that correctly. Now we'll save this, and now let's rerun the test. So this needs to do a little bit more analysis because we've changed the source code. And then it's going to execute all these functions. Now, of course, I need to perhaps unsuspend that. We'll do that later. But let's see if this just runs correctly for the moment. Okay, generating some reports. And there it's now building and executing the test cases. And what we should find is this time it all runs okay. So code is behaving the same as before. We can see that all these tests have still passed. So what I'm now going to do is I'm now going to unsuspend this test case, and let's run them again. And hopefully this time that test should now pass. So there we can see executing using the Green Hills integrity. And there we can see the test doesn't pass because obviously the behavior is slightly different, but at least the code has executed. And we now have code that is more robust than it was before. So very briefly, that's a quick overview of performing some robustness testing. And if you'd like more information, then please don't hesitate to contact us at LDRA. Thank you.